Addressing GFCI tripping issues during home electrical hot checks involves several possible solutions. One approach is to use a GFCI tester to ascertain the type of GFCI breaker installed on the T-pole. Some GFCI breakers feature a test button, enabling temporary disabling of the GFCI protection, which could allow for a hot check without tripping the breaker. Another option involves temporarily bypassing the GFCI breaker located in the T-pole using a jumper wire. This action disables the GFCI protection, permitting a hot check of the home. A third option is to employ a dedicated generator, connecting it to the home's electrical system. This isolates the home from the T-pole, thereby eliminating the GFCI breaker issue. However, when using the bypass or generator options, adhere to stringent safety precautions. Firstly, wear appropriate safety gear, including insulated gloves and safety glasses. Secondly, turn off the main breaker in the home before making any connections. Thirdly, diligently follow all local electrical codes and regulations. The utilization of a floating neutral is strongly discouraged due to the potential safety hazards it presents. Maintaining proper grounding and bonding is paramount to ensure the safety and integrity of the home's electrical system. Let's delve into these options with more detail, emphasizing the technical aspects and safety considerations. Firstly, understanding GFCI operation is crucial. A GFCI, or ground fault circuit interrupter, is designed to protect individuals from electrical shock. It works by monitoring the current flowing to from a device or appliance. If there's an imbalance, even a small one, typically around 5 milliamps, the GFCI trips, quickly cutting off the power. This imbalance usually indicates that current is leaking to ground, potentially through a person. When performing a hot check on a new home, the electrical system is temporarily powered from a T-pole, which is a utility pole with a temporary service panel. This panel often includes a 50-amp receptacle for powering larger loads. Modern T-poles are required to have GFCI protection on these receptacles. The issue arises because the home's electrical system, once the meter is installed, has a bonded neutral. This means the neutral wire is connected to the grounding system at the main service panel. When the home is powered from the T-pole, this bonded neutral can create a parallel path for current to flow back to the source, the T-pole. This parallel path can cause a slight imbalance in the current flowing through the GFCI breaker on the T-pole, leading it to trip. Addressing this requires careful consideration to avoid creating unsafe conditions. Option 1, utilizing a GFCI tester, is the safest and often the most practical approach. These testers are designed to simulate a ground fault condition. By plugging the tester into an outlet in the home and pressing the test button, it draws a small amount of current to ground. If the GFCI breaker on the T-pole trips, it confirms that the GFCI protection is functioning correctly. However, the primary purpose here is not just to test the GFCI, but to potentially identify a way to work around the tripping issue. Some advanced GFCI testers have settings that allow you to adjust the amount of current they draw to ground. By carefully increasing the current, you might be able to find a level that allows you to perform your hot check without tripping the GFCI. This requires a bit of experimentation and a good understanding of how GFCI breakers respond to different levels of ground fault current. It's also important to note that not all GFCI breakers are created equal. Some are more sensitive than others, and some have features like nuisance trip reduction, which can make them less prone to tripping from minor imbalances. Identifying the type of GFCI breaker installed on the T-pole can help you understand its characteristics and how it might respond to different testing methods. Option 2, temporarily bypassing the GFCI breaker, should only be considered as a last resort and requires extreme caution. Bypassing the GFCI protection eliminates the safety feature designed to prevent electrical shock. To bypass the GFCI breaker, you would need to carefully disconnect the load wires from the breaker and connect them directly to the incoming power wires. This effectively removes the GFCI breaker from the circuit. However, doing so leaves the circuit unprotected. If there is a ground fault in the home's electrical system, there will be no protection to prevent electrical shock. This is why it is crucial to take every possible precaution. Firstly, ensure that the main breaker in the home is turned off before making any connections. This energizes the entire electrical system, reducing the risk of accidental contact with live wires. Secondly, wear appropriate personal protective equipment, including insulated gloves and safety glasses. Thirdly, double-check all connections to ensure they are secure and properly insulated. After bypassing the GFCI breaker, perform the hot check carefully, looking for any signs of electrical problems, such as loose connections, damaged wires, or evidence of overheating. If you find any issues, immediately disconnect the power and address the problem before proceeding. Once the hot check is complete, restore the GFCI protection by reconnecting the wires to the GFCI breaker. Ensure that the breaker is functioning correctly by testing it with the GFCI tester. Option 3. Using a dedicated generator offers a safer and more reliable way to perform a hot check without GFCI tripping issues. A generator provides an isolated power source, which means the neutral is not bonded to ground in the same way as the utility service. This eliminates the parallel current path that causes the GFCI breaker on the T-pole to trip. To use a generator, you would need to connect it to the home's electrical system using a transfer switch or a generator cord. A transfer switch is the preferred method as it provides a safe and reliable way to switch between utility power and generator power. It prevents backfeeding power into the utility grid, which can be dangerous for utility workers. A generator cord can be used if a transfer switch is not available, but it must be properly sized for the load and connected correctly to avoid electrical hazards. When using a generator, it is important to follow all safety precautions. Firstly, ensure that the generator is properly grounded. Secondly, operate the generator in a well-ventilated area to prevent carbon monoxide poisoning. Thirdly, do not overload the generator. Check the generator's wattage rating and ensure that the total load connected to it does not exceed that rating. Once the generator is connected and running, you can perform the hot check as normal. The absence of a bonded neutral should prevent the GFCI breaker on the T-pole from tripping. Finally, the idea of removing the neutral bond screw and the neutral that goes to the meter is not recommended. This creates a floating neutral condition which can be very dangerous. In a system with a floating neutral, the voltage between the neutral and ground can fluctuate, potentially causing damage to equipment and increasing the risk of electrical shock. The neutral bond is essential for providing a stable reference point for the electrical system and ensuring that ground fault currents can flow back to the source, tripping the breaker and preventing electrical shock. Maintaining proper grounding and bonding is crucial for the safety of the electrical system. It ensures that all metal parts of the electrical system are connected to ground, providing a path for fault currents to flow back to the source. This helps to quickly trip the breaker and prevent electrical shock. In summary, when faced with GFCI tripping issues during home electrical hot checks, several solutions are available. Using a GFCI tester is the safest and often the most practical approach. Temporarily bypassing the GFCI breaker should only be considered as a last resort and requires extreme caution. Using a dedicated generator offers a safer and more reliable way to perform a hot check without GFCI tripping issues. Above all, avoid creating a floating neutral condition as it can be very dangerous. Always prioritize safety and follow all applicable electrical codes and regulations. Before undertaking any electrical work, firstly, ensure you are qualified and competent to do so. Secondly, always energize the circuit before making any connections or disconnections. Thirdly, use appropriate personal protective equipment, including insulated gloves and safety glasses. Fourthly, double-check all connections to ensure they are secure and properly insulated. Fifthly, test the circuit after completing the work to ensure it is functioning correctly. By following these safety precautions, you can minimize the risk of electrical shock and ensure the safety of yourself and others. Furthermore, consider consulting with a qualified electrician if you are unsure about any aspect of the electrical work. Electricians have the knowledge and experience to safely and effectively address electrical issues. They can also ensure that the electrical system is compliant with all applicable codes and regulations. Remember, electrical safety is paramount. Always prioritize safety over convenience or speed. Taking the time to do the job right can prevent accidents and save lives. To reiterate the options, firstly, use a GFCI tester to attempt to work around the tripping issue. Secondly, consider temporarily bypassing the GFCI breaker only as a last resort with extreme caution. Thirdly, use a dedicated generator as a safer and more reliable alternative. And absolutely avoid creating a floating neutral condition. Always prioritize safety and adhere to electrical codes.